Let's take a look at an application where you can really see these curves coming together in a real-life situation. In fact, this one circles around an island. So a tour boat travels around a small island in a pattern that can be modeled by the equation Gyunk. Now, look at that equation. I can recognize that. Can you? I see the x squared plus a y squared. It equals something positive. This tells me it's a circle. This is a circle centered at the origin, and its radius is the square root of 400. See how quickly I sort of think about that? I'd like you to, I'm sorry, the radius is the square root of 400. I want you to try to look at these things and try in your head to get a mental guess as to what you think they are. And the island is the origin. Oh, perfect. So we know it's centered. We know this path is centered at the origin. So in fact, this is a tour boat that's going right around the island, making a perfect circle where the island is the center. Now suppose that a fishing boat approaches the island on a path that's modeled by that equation. Now what's that look like? Well, I look at that. I see that the x's are squared. There are no y squareds. So this is going to be a parabola. It's going to be either a happy face parabola or a sad face parabola. Which one is it? I see a negative 1/8 as a coefficient in front of the x squared part of it. So this is going to be a sad face parabola. So I've got a sad face parabola, and I've got this circle. And the question is there any danger of a collision? So let's just think about this visually. All right, so I've got this circle lassoing around the origin, and then I've got the sad face parabola. Now, I don't know if the sad face parabola is going to sort of come up and just miss the whole circle completely, like this, or will that actual path intersect the circle? That's the question. Well, how are we going to figure that out? Well, there are lots of ways. We've already seen elimination as a method of actually solving the system. Here's the system in its entirety. We want to find out if, in fact, these two equations actually have a point that satisfy both. If they do, if there is a solution, then in fact these two curves will intersect, which means that the boat and the fishing boat and the tour boat will intersect as well. Well, so we could use elimination, we can use algebra. There are lots of methods we can use, substitution. But the point is that we could also look at a picture. If we take out a graphing calculator, we could actually put in these curves. Now, if you want to do this, you could call this, for example, the first function. You'd have to solve this for y, call this y1, and you'd have y1 equals 12 minus 1/8 times the quantity x plus 16 all squared. Call that y1. You'd have to actually solve this for y, and when you do that, you see there's two solutions. You see that y will equal plus or minus the square root of 400 minus x squared. So you have to enter that in as two functions. So you might have y2 equal minus the square root of 400 minus x squared, and you could have y3 in your calculator equal plus square root of 400 minus x squared. Then you have those three curves together. So the three curves mean that one curve will make the upper half of the circle, and the second curve will make the bottom half of the circle, and then the last curve here, this y1, will actually be the parabola, and you can look and see if, in fact, we have an intersection point. Well, I've graphed it for us here, and you can see what we get. Well, here we see the circle centered at the origin, radius square root of 400, which, of course, is 20, so you can see that right here. And then here's that sad face parabola that we promised, and you can see that, in fact, does this make sense? Is this really okay? Well, we know what the vertex should be. The vertex should be at negative 16, 12, and notice negative 16, 12, that in fact is where the vertex is, and in fact, moreover, it seems to be a point of intersection. So it seems like we're actually going to intersect right at that vertex, and we also seem to be intersecting way down here. Now we can actually check these answers and see if they're correct. Let's read them off first. This is going to be negative 16, comma 12, and here we read off 0, comma negative 20. So are these solutions? Well, let's actually plug them in and see. So if we check, we have to now take these points and insert them not just to one, but to both. So when I insert them here, what do I see? Well, I see negative 16 squared, which is just the same thing as 16 squared. So I have negative 16 squared plus 12 squared, which is 144. And when you add them together, we do, in fact, see 400. So that checks. Good. Now, what about the second equation? Well, here I'm going to put in y equals 12. So I see 12 minus 12, that's 0 on this side. And what do I see on this side? I put a negative 16 here. I see negative 16 plus 16 is 0, squared is 0, times negative 1/8 is 0, and so that checks as well. So this point satisfies both. This is indeed the exact solution. Let's see if this one is as well. when I let x equal 0 and y equals negative 20, I let x equal 0, that's 0 squared is 0, plus negative 20 squared, which of course is 400, and that does equal 400, so it checks. And what about the last thing? Let y equal negative 20, so I have negative 20 minus 12. Does that equal negative 1/8 times 16 squared? Well, on this side, we see minus 32. And when we square 16 and then divide it by 8 and put a minus sign in front, we do indeed see 32. So in fact, both of these check. So in fact, both these are solutions. Now, you could also find the solutions to these algebraically. And what you might want to do, in fact, is actually solve this for, let's say, y. I could have y equals, bring this over to the other side, as a plus 12. I'd see 12 minus 1/8 times the quantity x plus 16 all squared. And then take that whole value for y and insert it here. So square it. So square that big thing and carefully FOIL everything out, combine the like terms with this x squared, and then bring the 400 over and factor that. And you'd get the two answers, and then you could figure out what the y value should be. So you could also check this answer algebraically as well. It'd be a bit of work, but I think it would be excellent practice. And actually, I invite you to do it if you want to try it for yourself. Anyway, the important thing is that when we have systems of equations, we can put them together algebraically, we can put them together visually, graphically, and we can see the points of intersections. The answer to this question, by the way, is absolutely the paths of the tour ship and the path of the fishing boat will, in fact, coincide. So these two vessels have to be careful. They might actually be on a collision course. I'll see you soon.